Welcome to qnawire.
In this question, we have to use Newton's second law, and for that, I'm choosing the following reference frame. This axis that I will call the y-axis, and this axis that I will call the x-axis. Then, using this reference frame, we can apply Newton's second law to the box. Then, by doing that, we get the following. For the y-axis, there are three forces acting: the normal force, a component of the weight force, and also a component of the force F. It's easier to see if we draw the components. The vertical component of the weight force is this one, Wy. By the way, it also has a horizontal component, Wx. The vertical component of the force F is this one, F component y. And this is the component x of the force F, Fx. Also already notice that this angle is opposite to this angle. Therefore, both angles are 20 degrees. Then, now going back to Newton's second law, we see that the net force is equal to the mass of the crate times its acceleration. Since it's resting, the acceleration is equal to 0. So the net force is 0, but the net force in the y direction is composed by the normal force that points to the positive y direction plus the force F, y component, that points to the positive y direction, minus the weight force, y component, that points to the negative y direction. And this is equal to 0. With that, we see that the normal force is given by the weight force, y component, minus the force F component, y. Now, we have to relate the y components with the magnitudes of the vectors. So, for the vector F, we have the following. This is the magnitude, and then we have this component and this component. Together they form a rectangle triangle, where one side is the y component and another side the x component. This angle is an angle of 20 degrees. Then, we can calculate the y component by using the sine of 20. So the sine of 20 degrees is given by the opposite side, F component y, divided by the hypotenuse, F. Then, F component y is equal to F times the sine of 20 degrees. For the x component, we have that the cosine of 20 degrees is equal to F component x divided by F. Therefore, the x component of F is given by F times the cosine of 20 degrees. Now, for the weight force, we can do something similar. But before, we have to discover what is this angle. For that, we can do the following trick. So we can extend the weight until it meets this point. Then this forms a rectangle triangle. Then, this angle is 20. This angle must be something that when we add up with 20, compose 90. Therefore, it must be an angle of 70 degrees. So this is 70 degrees. At the same time, this angle is a right angle. So 70 degrees plus this intern angle must be 90, meaning that this intern angle is also 20 degrees. Then, using this information, we can draw the triangle for the weight, which is as follows. So we have this side, and that side. This is the hypotenuse, this is the y component, this is the x component, and here we have a 20-degree angle. Then, using the sine of 20, we calculate the x component. So the sine of 20 is given by the x component divided by the hypotenuse. Therefore, the weight component x is given by the weight times the sine of 20 degrees. By using the cosine, we can calculate the y component. The cosine is the adjacent side divided by the hypotenuse. Therefore, the weight y component is given by w times the cosine of 20 degrees. Now we can go back to the normal force. Using these informations, the normal force is weight times cosine of 20 degrees minus F times the sine of 20 degrees. And then we can remember that the weight is given by the mass times the acceleration of gravity. So the normal force is given by 225 times 9.8 times the cosine of 20 degrees, and F is 535 times the sine of 20 degrees. This results in a normal force of approximately 1889.041 newtons. Now we keep this value and proceed to apply Newton's second law on the x direction. For that, let me organize my board. Okay, now applying to the x direction, we get that the net force is equals to the mass times the acceleration of the crate in the x direction. The crate is at rest, its acceleration is again 0. So notice that the net force in the x direction is composed by 1, 2, 3 forces again. The frictional force and the x components of W and F. The frictional force points to the negative direction, but the others point to the positive. So Wx plus Fx minus frictional force is equals to 0. Then the frictional force is equals to the weight x component plus Fx component. We can calculate these components using the equations we have. So Wx is W times the sine of 20 degrees plus Fx, which is F times the cosine of 20 degrees. Now we can plug in the values that the problem gives to get 225 times 9.8 times the sine of 20 plus 535 times the cosine of 20. This results in a frictional force of approximately 1256.890 newtons approximately. Now, knowing the frictional force and the normal force, we can calculate the static frictional coefficient, because we know that the friction is given by the static frictional coefficient times the normal force. So the static frictional coefficient is the frictional force divided by the normal force, which is 1256.890 divided by 1889.041. This results in a static frictional coefficient of approximately 0.666, and this is the answer to this problem.